So we're going to try to get this one into standard form. So once again, we're going to have to go ahead and complete the square. Notice our y's are being squared, so we're going to have to get it in the form like what we have over here on the right, where the y's are being squared. So we need to complete the square with the y, so I'm going to get the y's on the same side, so I'm going to have to add that y squared to both sides. Then I want to go ahead and group or get rid of the 4 in front of my x, so I can have x equals eventually here. Then, after we do that, we get this. But, oh, yeah, complete square with the y's. I need to have the y's grouped together, so that's what I have. I have the y's grouped together, but remember, I only want to have a 1 in front of my y squared. So I can take a 1/4 out of my y's, just out of my y's. Still leave my 13/4 out back. Now, 1/4 is still going to be in front. Take half of what's in front of my y, which is a 1, and go 1 squared there. Now, if I add something on the right side of the equal sign, I need to offset that by subtracting it. So I need to subtract this. You might be wondering, where the heck does that come from? Well, I added the green 1 squared here, so I need to subtract that. But this green 1 squared here is affected by that 1/4 in front, because 1/4 applies to that green. So I need to subtract that 1/4 times the green. So then I factor it to get it into the proper form. Then if you needed to, you could find your vertex, which remember we're going sideways, so it would be 3, -1. Now, on this one here, it's already in standard form, and then you need to go ahead and find all that stuff. This one's opening up and down, so remember that means this is the x-coordinate of your vertex, this is the y-coordinate of your vertex, opposite of what's in the parentheses, same as what's outside. It's positive in front, so that means I got to be opening in the positive direction of the y's. So if I plot that point, I'm over 1, down 5, I get this here. Now when it comes to getting this whole shape right here, we'll get to that in a bit. Just be patient. So to be able to get that table, all we have to do is to go ahead and look at our x's. Now, we're concerned about the x's because we have our x-coordinate here. We know we're opening up and down. We can then go ahead and plug stuff in for this x right here. So I'm going to put down the x-coordinate of my vertex right there. Choose 3 numbers on each side. And then all I have to do then is just plug those into my original problem. Figure out the y values and plot those points. Now, a little bit ago, I told you about that 1, 3, 5, 7 pattern. That works great, except we have a 2 in front. So we basically have to double that pattern. We start at a vertex, go over 1. We normally go up 1, but we got to double that because of the 2, so we go up 2. Normally we go over 1 and up 3, but because we have a 2 in front, we have to double that, and we go up 6. Same idea the other way. Over 1, double that 1 to go up 2. Over 1, double that 3 to go up 6. And plot your points. And that's how we can get the blue graph, either from that pattern or from our t-chart. Once we have the blue graph, we can see it's easy to get our axis of symmetry that cuts it in half. It's a vertical line going straight up and down, so it's x equals 1 because it goes through the x-coordinate of our vertex. Then we have to use that 1 over 4. So we go 1 divided by 4a, so we'll go 1 divided by 4 times 2, or 1 over 8. So we have to go 1/8, since we're opening up from our vertex to get to our focus. If we go straight up, that does not affect the x at all. So we have to go to our y-coordinate of our vertex, go up 1/8, so we get our focus to be 1, -39/8. Our directrix then would have to be 1/8 of a unit in the other direction, so we'd have to be at a vertex and go 1/8 down. And it's always a line, it's always going to be perpendicular to your axis of symmetry, so it's going to then be a horizontal line. Well, if we're going 1/8 down, we're at -5, and we go 1/8 down. That gives us y equals -41/8. The length of our lattice rectum is always 1/a, should be 1/2 or 1/2, and it's positive.